I'm really grateful to my friends at Zak who helped us to organize tonight. Tonight is meant to be as a precursor for tomorrow, where we want to focus the attention of the Zak conference tomorrow on the topic of sustainability. And a lot of the speakers that you will hear tonight should have really been with us tomorrow, but because of COVID, they cannot travel easily. So we have a speaker tonight from the Aluminium Stewardship Initiative, Fiona who is based in Australia, and it's not so easy to travel. We have somebody from Cradle-to-Cradle, Lena, who's based in Germany, and again, she couldn't travel. And the guy from Aluminium, Council for Aluminium and Building,
Justin, yeah, but he didn't. No, he's not here. No. We have a larger live audience, so if you can address them also, if you can come here, Stephen. Yeah, cameras here.
I should be talking. Sorry, live audience. Sorry, I focused. It's been a long time. It's been a while. But anyway, thank you to all the speakers who are not here, but a special thank you to Kevin. Kevin, if we can have you at the front, please. Kevin Hydes, who's the chairman, is that right? Chairman?
Yep.
Of Integral Group.
In the UK, we know it as Eminent.
Yeah. And we're so happy to have you in person. It's wonderful to have a live speaker. Ahad will introduce everybody properly in a minute, but I just want to give you a few basic hints. If you need the loo, it's just through that door. If there is a fire, hopefully there isn't, the fire exits through this door as well, and also through the front door upstairs.
The ancient windows will protect us.
Yeah. And so from my side, that's all I want to say. I want to say thank you for coming, and I want to hand to Ahad to introduce the speakers and kick us off.
Right. What happened? What happened?
Okay.
It's a loose connection. Just a second. Okay. Is the live stream okay? Yeah. Yeah. Hi. So good. Stephen. Stephen. I got to keep holding it over?
No.
Okay.
Just keep your finger on it. Just stay there for about that.
Right. So good evening, everyone. Welcome to this curtain raiser of the 79th edition of the Zak World of Façades conference. As Stephen mentioned, this was an idea which we planned a month ago when we met. We had a lot of speakers whom we wanted to accommodate at the event tomorrow, but it's already a packed agenda. There were commitments from 2020 and 2021. This event was originally planned for October 2020, but didn't happen. So what better way of live streaming it? It's the in thing now. Live streams, I know there's a big burnout, but probably this is the last time we'll be doing such kind of live stream. I hope in-person events are going to be the thing going forward from now. As Stephen mentioned, we have 4 speakers talking today. One is in person. We have Kevin Hydes. He's the chairman and founder at Integral Group. He's going to be talking on climate, carbon, COVID construction. We have Fiona Solomon. She's from Sydney, Australia. She couldn't travel here, unfortunately. She's going to be talking on the Aluminium Stewardship Initiative, responsible production, sourcing, and stewardship of aluminium. You have Justin Furness from the Council of Aluminium Building here in the UK. He's going to be talking on what no D, when whole life means whole life. And you have Lena from Cradle-to-Cradle NGO from Berlin. She's going to be talking on the Cradle-to-Cradle design concept for a positive footprint. I'll quickly introduce our speakers. So Kevin's here with us. So Kevin has 30 years of experience as an engineer. He's also a CIPSI fellow. He is Integral Group's founder and first president. I believe Integral Group is now part of the Dar Group. So all of you know the Dar Group. They have Perkins and Wills, they have Murphy's, they have a lot of other companies together. So Integral are part of this group. So Kevin will be talking on climate, carbon, COVID construction. Fiona is the CEO of the Aluminium Stewardship Initiative. She joined in 2015. She's responsible for the development, implementation of ASI strategy and operations. Justin is a senior consultant at CAB, which is the Council of Aluminium and Building, and he has over 10 years of experience, and he will be talking on what no D when whole life means whole life. And then we have Lena Junker from Cradle-to-Cradle. Cradle-to-Cradle is a common German sustainability trait, which is now catching up. She's going to be talking on what Cradle-to-Cradle is and how it helps for a positive footprint. So these are our speakers for today. So Kevin will be presenting live. The other three are pre-recorded and they will be streamed. Once Kevin is complete, the in-person audience over here, we can disperse and we can network, unless somebody would like to sit and watch the other three presentations. While for our live stream audience, the presentations will continue for the next 45 minutes after Kevin completes his talk. So that's it from me. I thank you all for being here. Hope you enjoyed today's evening and hope to see you all tomorrow. So ladies and gentlemen, Kevin Hydes from Integral Group.
Probably time to leave after that clap, you know. Yeah, thanks. It's been interesting. I live in San Francisco, California, and I came to London. I've been here for the month. When I first got here, there was a few people on the streets. The bars were. Camera here, if you don't. Oh yeah, sorry. When I first got here, very few people on the street. The bars were just kind of open, and every second restaurant was open every second day. And of course now, you know, London's back, right? And it's kind of great to see. I know the ridership and the TfL is only at 50%. I heard that from somebody at TfL last night. But there's kind of a growing momentum. And of course, throughout the pandemic, the construction industry kept on building. So when I last came here, it was 18 months ago, and I've seen some of these incredible buildings in the city completed since then. So I thought I'd talk about these four things because, you know, they all kind of connect to each other. And we talk about these things sometimes separately, but they're all interconnected and they all sort of influence where we need to go. So, so just a few slides on our firm. I did create the firm intentionally around a firm that would care about the planet and really focus on deep green engineering solutions, working with architects, builders, developers, and whatnot to get a better outcome.
Kevin, sorry, I don't think people are going to hear you at the back. If you can also move to the side because online they can see the screen.
Yeah, they can see the screen. They won't see him. That's fine. So yeah.
So you can, yeah. So and if you can think of the guy right at the back.
Who's got the little steering at the back? Right. Can you hear me? Oh, Jesus.
But he need to push the slides from here.
Closer.
But you need to come here to push the slides.
Guys, the seats at the front are empty.
Yeah. Come on up. All right, can you hear me now better? Good. Higher? Good, all right. So, this is our firm. Started 12 years ago, and that's where we've got to. I'm going to be talking about the work within our firm that's done by these individuals and their teams that are scattered in the offices around the world that we operate from. And they operate as a single team focused on global issues. Now, this is a really important slide. We're all part of a bigger network. You know, we have our own individual businesses. Just like tonight, we're connecting as some of us are probably competitors, some of us are collaborators. We're from different sectors of the construction industry, which is the largest industry in the world, employs 200 million people. And we've all got to get better, quicker, to do the work that needs to be done. So you might see some names up there from your own businesses. See Bruce Nichols here. Do you see your business?
So, yeah, it's the Hydes now, Kevin.
Oh, right. I'm going to get it wrong. That's Merck High Rise now, is it, Bruce?
Stay here. It's the mics here. Stay here. Itself.
I'll just say next.
I said, you stay here itself. It's better because the mic's here.
Oh, yeah, right,
The mic's here. So don't worry. I think people can hear.
In front, but on this side.
Just come. Mic's here. Yeah, this is perfect.
That's good.
Yeah.
I can do that.
Yeah.
I'll tell you, I tried a career in Hollywood, but it didn't work. So anyway, but think about these connections that we've all got with academia, with industry, with the whole supply chain. It's really important that we communicate effectively together and we stop confusing people. I mean, the scientists have told us there's no more confusion. The facts are the facts. can stop deliberating. We don't any climate deniers can leave the room at any time. It's not acceptable. So, you know, there's this increased temperature we know about. This was the last report that came out just in May from the scientists about what they think. And the telling is we've got some choices in front of us to make. And we can have a really, really bad future, or we can have a series of reasonable or better futures. And I think this is what we're going to hear a lot of conversation around in the next couple of months leading up to the COP26 in Glasgow, which we're all familiar with. Increasingly, every business, every industry, every community needs to get in line with the UN SDGs, because that's going to be the language of your clients and of your colleagues and of your governments. So we have to start to communicate in terms that are really global in nature at all levels, internally and externally. COP26, first 2 weeks in December. Has anybody been to a COP event? Anybody been to a climate change event? I've been to a couple. It's a bit of a circus, and it's really national politicians trying to get things done, but often having problems. Around the COP is where industry meets. But we've never ever had in 26 meetings a day on buildings. You guys are all from the building sector. We've had hydrogen, we've had clean coal, we've had renewables, we've had batteries. We've never had a buildings day. We've got the buildings day for the first time ever. So we're going to be much more in the conversation, and statements are going to be made which affect everybody's day-to-day job in this room, guaranteed. It's different than before. And then we've got these great organizations that are organizing that day, and they're going to be talking about all the things we need to talk about. Because the news doesn't stop. Whether it's condensing boilers coming out of a terrace house in Leeds where me and Bruce were born, whether it's the worst air quality Paris has ever seen recently, or whether it's, you know, increasing drought everywhere. I live in California. We've had no rain for a year. The lakes that serve my town are bone dry, and the forests are on fire. So that's the truth. That's the truth. So when I started working, we talked about energy conservation. We'll make some buildings and we'll get some nice glass, some nice facades, get some nice equipment, and we'll have an efficient building. Probably 20 years ago, we started saying that's not good enough. We have to start talking about net zero energy buildings, which we did. We started to design them, we started to build them, we started to operate them. That's not good enough. Then we started talking about net zero carbon buildings in Europe 20 years ago, in North America 10 years ago. Now that's all the conversation is with every global client that I work with, and I work with a lot. And now the next frontier, whole life cycle carbon. The thing that, if you're in the facade business, is probably the most important thing you've had to face in your professional lives. You know, because there's a lot of politics that are driving why we've got to change. This is Brooklyn, New York, and we did a study near the power plant. Turns out that it's the poorest neighborhood in the city, and it's got the highest rate of asthma because they live next to the power plant, and they're choking to death. So that's got to be stopped. New York will stop that. And of course, we've got tools today that we didn't have 40 years ago that help us better understand what our buildings might be. Rather than being energy users, they could be energy generators. They could be doing much more than they've done traditionally. And some buildings are in this town and other towns are already starting to do that. But I think that needs to become the normal practice. It needs to become the normal mindset. You know, because again, we've got enough sophistication. I've got an office in New York. Everybody's a MIT PhD, and they can knock out models in days that used to take us months, if not years. So the capability is with us to make smarter choices quicker. And we need to make those smarter choices quicker. There's also the comfort needs to be understood as well, not just the consumption, the energy or the production, but do people even want to be in these offices? I've got my friend in the room, Martin Gettins. How many people are in Canary Wharf, Martin?
Not enough.
Not enough, yeah, so send your clients to Canary Wharf, but it's 100,000, right?
Yeah, it's 100,000 on a good day, probably around about 60, 70 at the moment, 60, 70,000. So we're coming back, but not quick enough.
Yeah.
So to your point, we need to attract people into workspaces.
Exactly.
Yeah.
It's got to be comfortable, it's got to be healthy, and it's got to have the right image. So that's enough for that for now. We've all had an 18 months in our life, like no 18 months ever before. This diagram I found the second week into the pandemic. I've been using it ever since. This is what happened. The shit hit the fan, and we all stopped. We all went away from work, and we went down the mine shaft, as I call it. The last 18 months, we've been in that bottom of the mine shaft, a mine tunnel, and we've been going back to work a bit. No, we're going to stop. Governments have been opening up and locking down. This was predicted by the scientific experts who knew what this pandemic would look like. We were thinking it might go away in a couple of weeks. This is an 18-month-old slide. It's so true. So now we're coming out. Now London's back. We're going to get full back party. But we've got to get to the future now, because we just lost 2 years. So we've got to be better than before. Not the same as before, because we lost 2 years at working on climate-related topics. And we've got to get back to them. So the future has to be brighter. We have to thrive. We have to be healthier. We have to work on helping the planet. It's everybody's job in this room. Our clients, global occupiers like Google, their people are going back to work, but not only that, they're spending fortunes on their new development. Google's the biggest real estate developer now in North America. They used to get other people to build buildings and they occupy it. Now they've got lots of cash. So they're going to build their own buildings and they're going to build them the way they want them, which means respecting the planet, doing all the right things and moving forward. You know, we wrote a document 2 years ago, British Council of Officers, Wellness Matters. We were the primary authors. We talked a lot about, you know, what does a healthy building look like? Well, during COVID, I'm a mechanical engineer. Nobody ever knew what I did. Now everybody knows what I did, because it was in the front page of all the newspapers saying, you know, these buildings over, that air comes in there and then it goes out there and it goes between me and another person before it goes out. I'm not going back to that space. So our little industry became top of the pops. And people were interested in filtration. They were interested in displacement ventilation. They were interested in whether it was a healthy, safe space to go to work. And they're still going to be looking and asking for those questions. You know, we can, you know, when we started to look at our projects we were already designing, you know, we wanted to better understand how's the air moving around. And there's lots of tools like this. These used to be, you know, $1 million to do something like that. And you have to wait a year for a result. I mean, these are done in minutes and hours. Quick analyses, give us information, give us what we need, and then we can interpret. You know, so obviously we work on facades, just like all you do. And, you know, we need to understand what bits of the facade are going to open, if they're going to open, when are they going to open, what time of day, what time of year. Is it when the energies, like where I live, we lose power. Anytime it gets over 30 degrees Celsius in California now, the electricity company shuts off the grid, because it's the thing that causes the forest fires, which are burning the forests. They're already bankrupt. So we lose power outages all the time now in a big, sophisticated place like California, because we went too far. So now we're drawing it back in. This is a project that took me to California in 2000. This is the headquarters of the Packard Foundation, HP, David and Lucille Packard. And even back then, when I went to design this building, we knew people wanted to have access to nature. People wanted to have the sense of indoor and outdoor. And yeah, you can do it at this level, at this scale, in a suburban office park in Menlo, you know, near Palo Alto, near Stanford. But you can do it anywhere else as well. Our tall buildings are doing this. So a great example again at Canary Wharf, that, you know, if anybody's not been there, the new transit connection with that inside, you know, horizontal park. I mean, it's unbelievable. We've never seen it before, you know? So there's a lot we can do, there's a lot we're doing, and we need to do more. You know, I couldn't, I mean, I fell over myself when I got here. I went to see Peter Murray at the NLA, because they're now up at the cold drop yards. If you want to know what a really smart, embodied energy, cool design, indoor, outside, the best place in London that we want to be right now, just take a visit there. And it's got the new glass and new technology in the verticals, but it's retained a lot of the other stuff. A great piece of work. And when the Google headquarters next to it at King's Cross opens, there'll be another 6,000 people using that space. It's incredible. Oh, now the machine.
Again.
There you go.
It's this motion here. Yeah, again. That's it.
There you go. So this is the American University Beirut. If anybody's been to Beirut or knows what's going on in Beirut, you probably know that every day, every building loses power because we don't have the diesel. So we were designing this job 2 years ago now, where we said, well, how can we get this computer to work? What's that diesel genset?
Worked fine yesterday.
Yeah.
Yeah. Now just leave it. Just leave it.
I won't touch it.
Oh,
It's like,
come on.
Sorry for those
Sorry, yeah.
who are streaming in. So we get some technical difficulties, but
For them, it's fine.
there we go.
It's only the screen here.
Oh, so you don't know what I'm talking about. Well, I probably sound like a bit of a raving lunatic. Anyway, that's the image I wanted to show. So this is again. Well, it seems like anytime I move near the thing. So anybody got any duct tape?
I don't know what we should. Just a sec. Let's look. Yeah, okay.
Good?
Yeah.
Just that image.
Hopefully.
Didn't like that image, sorry. Anyway, it's a hospital, and we were trying to design a hospital in a tough climate that's got dodgy power that people would be healthy in. And if they did lose power, it would continue to operate for days, not hours, with the diesel generator and its storage. You know, we wanted to do with a battery, quite frankly, but the university wasn't quite ready. They will be next time, because they've got much worse power now than they had when we were designing. So if we designed with a good facade, which I showed you briefly, we found out we could make the systems much smaller, and the emergency generator could last 4 times as long. So it could go for days, not for hours. So that's the benefit of smart design and smart facade thinking. You can actually operate your systems much longer. It's still going, okay? Yeah. So these things are interrelated. That's where we'll go.
Just a second.
I had
What do you want me to do?
Stand there.
yeah, press it again. Press it again. That's it.
Okay, right.
So I'm keeping everything. I'll keep this. I'll use the other finger. Probably the wrong finger. So anybody that's already working in London needs to know that any major scheme, what they call a referred scheme within the GLA, has got a mandatory requirement for embodied calculation right now, not sometime in the future. So all the big schemes that you're probably working on, they're asking for this information. So if you don't have it, you're not going to get your permit. So that's not old news, that's new news as of March this year. You know, we did this school next to BedZ. They did from our office here in London. You know, and we were always thinking about the materials. We're always thinking about the wood, some nice glass opening windows, and I think that was good. And we could assess it now because we have better methods of assessment. We heard about Cradle-to-Cradle. It's the original, but there's a lot more guidance now out there to help manufacturers, designers, builders to get to higher levels of embodied carbon life cycle results. And if you know, again, I'm speaking to the facade people in the room, if you can help your designers and your builders come up with a really much better facade that allows you to downsize the engineering systems, you'll save 40%. Because we can make bigger pipes smaller. Bigger pipes are cheaper, so it's good for the owner, and bigger pipes have got less embodied carbon. It's a really simple relationship. So we want to see things like this inside the buildings. We want to see straight pipelines, not elbows everywhere, not things going up and down, because that costs more money and it's got more embodied carbon. So we got to get better at planning how things get around buildings. Seems like a minor detail. It's a huge detail. Less pipe hangers, less embodied carbon, etc. To pay for the facades, but they're going to be more expensive. So you got to pay for them. The clients don't have any more money. They've got a budget. So, you know, the life cycle, we're going from issues that are affecting climate change. Some of the refrigerants we're using are still having a problem with ozone deletion, so we can't ignore that. But acidification of the oceans as we have more emissions, and on and on and on. And you know, the water use being the one that, you know, that I'm concerned about in my town. And again, we got methods. This is the end standard. It's out there. We can use it. We can use it on every job, not just certain jobs, and then start to identify the various elements that we're interested in knowing more about, and ultimately reducing. And at different times, some of these different systems are going to use more or less carbon. So it's change, you know, it's replacement cycles are a big issue. And then of course, at the end of the building's life, do we knock it down, or do we find a way to preserve it like coal drops and get another 100 years out of it? It's a choice. Is anybody in the room from Hawkins Brown?
They'll be there tomorrow.
Yeah, so this is their work. I just wanted to acknowledge it. They, just like us, they do work that affects the whole industry, and then they give it for free. So they've done this work on embodied. I'm not touching it.
It's the Hawkins Brown slide that the computer doesn't like.
Just
Just a second.
yeah, there you go. Anyway, it's been a great piece of work that's looking at different assembly methods for facade skins and looking at the carbon implication. Hopefully they'll talk about that tomorrow. So this is a really important slide to understand why is embodied carbon going to become the main topic going forward. Because as we make our buildings more efficient, from the big circle to the small circle, the percentage of the carbon we're using is more as a percentage in the materials that we're installing in the buildings. So again, just like Hawkins Brown, we've done our work, we do our research. Sometimes we do it with industry, sometimes we do it with academia, sometimes we do it with institutions, but when we do it, then we publish, and then everybody can use the same information. So, you know, the days are gone when people can hide and hold information. They have to share. You know, you have to share. And we got to break down those barriers. You know, so again, and so we love working with these institutions because their job is to share knowledge, not to hoard it. I think that's, I don't think that device likes that.
Yeah.
All right. Oh, no.
It's okay.
So, anybody in the room from Eckersley or Callahan? I mean, obviously, you know who they are.
Damien speaking on this tomorrow.
Yeah, so, you know, they again produced this independent piece of work, funded it themselves, and now shared it with the industry. So get to that session if you can. Again, it's showing in a different way how much more relevant, important embodied energy comes once we've dealt with the easy things that we know how to do with energy efficiency and renewable energy at the building level. I mentioned earlier, when we went with Bruce, not with Merck, it's with Hydes. I'm sorry about that, I got it right. But again, it's another, these are all pieces of the jigsaw puzzle. You know, this again is a different approach. This is liquid crystal glass, which we think is part of the solution. It's not the only solution, but it's going to be part of the toolkit, along with other things that are dynamic in nature. I got introduced to the head of the UK glass industry two lunches ago. You probably know him. He shared his slide with me. And yeah, he was so passionate about the amount of carbon that the UK glass industry is saved already. And you know, this is the way they're tracking it. And they think there's big moves ahead here in the UK. And the emissions are coming down. It's a big employer. It emits just like wherever you're manufacturing. It's a big emissions problem. So they got to get on with dealing with the emissions problem. And they've got their plans. And there you go. You may have some people in the room from those companies. But the glass industry was telling me, within Britain, the British glass, all the big players are getting together and all of them committing to a net zero outcome by 2050. So for an industry that by its very nature is very energy intensive, there are solutions and there are modifications and there will be changes in how glass is produced as we move forward. And then also on the supply chain, there's a lag between, there you go. So which is your beer of choice? Or is it Pearl or is it Heineken? But again, the glass industry sells a lot of its product to people that need to put things in containers, and they're also on a mission to zero. There's a lot of talk for quite a long time about CO2 sequestration. Maybe part of the glass industry solution is going to be sequestration. It likely will need to be. I'm not an expert in this field, but there are, and this will be talked about at COP26 as a primary topic, I would expect. And I do know there's so much work going on in this area that there's going to be solutions. There has to be, and they're going to be mandated at some point. There'll be voluntary efforts for as long as we can tolerate, and then new mandates. And back to circular thinking, in the Alan MacArthur Foundation, you know, this work really does capture effectively everything we're going to need to be thinking about and doing at all stages through the supply chain in the construction industry. And these are the things you're already talking about, but this is where we're going to need to go. We're going to have to design for disassembly, and that's obviously been talked about and started to happen more and more. And then the idea of the facade as a service. There's a number of, I know of people already working in this field where there's built-in liquid crystal screens, where you have your AV experience talking to the outside glass. It also is the backbone for the fire protection system, for the control system, for every system you need in a building. And what I think is brilliant about that is you get to commission your building much quicker, because the facade goes up before you put the final coat of paint on the last office that you built. So there's actually a speedier way to get your building completed. So I think much more of this, and whether as a service, you know, so it's a leased facade, it's not a purchased facade. People in the room are not in their heads. I think you know about this. How fast and who's going to want to go there? You'll find out because your clients will ask you. You know, and I think this disassembly, I think of it as like the IKEA. You know, we could all assemble an IKEA. So why can't we have that type of a drawing to figure out how to put together and pull apart our various things. And that's what we're going to expect. We can't always have the technocrats in the middle between the people buying and the people using. So there has to be more information. And like I said, these facade as a service ideas are definitely driving the idea of all the technology is in the skin. It's not in the core. It's the opposite to the way we've been doing buildings for 100 years. This is the Delft project. You're familiar with it. That's it. I survived. Thank you.
Thank you, Kevin. That was great. And my apologies for the technology glitches with that, but you persevered. You did fantastic. Thank you for that. Normally we would take questions, but I just want to close the streaming thing and let Ahad get on with that. Are you going to say anything or?
Yep. Sure. So thank you all for being here. The other three presentations will continue for our live stream audience. Let me just get that on for them, and then we can start. Can I request my team to play the other presentations? And then we can.
Hello, I'm Fiona Solomon and I'm the CEO of the Aluminium Stewardship Initiative. It's a pleasure to be here to talk to you about our organisation and the work that we're doing in responsible production, sourcing and stewardship of this important metal. It's a great pleasure to be here as part of Zak World of Façades and wishing you a really great event in the UK and globally. So let me start first with a bit of background on ASI and what we're about. Our vision is to maximise the contribution of aluminium to a sustainable society. And the way we do that is through our mission, which is recognising and collaboratively fostering responsible production, sourcing and stewardship of this important metal. We try to be inclusive in our work, and we have participation of representatives of a huge range of different stakeholder groups within and outside the industry. We aim to encourage uptake of our standards and our programs through bauxite, alumina and the aluminium value chain, from mining right through to downstream users such as this important sector. And we're trying to advance material stewardship as a shared responsibility in the life cycle of aluminium, whether that's around extraction, production, use, and of course, recycling at end of life. So our objectives are really standard setting, defining globally applicable standards for sustainable performance, and also chain of custody through the value chain. We really want to use those to promote measurable and continual improvements in key environmental, social and governance impacts of this metal. And to do that, we have a credible assurance and certification system that tries to mitigate the risks of non-conformity and support continual improvement. And we want to make sure that we as an organisation add value to our members, to advancing sustainability and to be inclusive of all of the interests of our stakeholders. We have a major standards revision process going on at the moment, and I'll talk a little bit about that, and a range of partnerships work and others that are really critical to us. So what's our progress? Well, we were incorporated back in 2015, so over, coming up to just over 6 years now. We're actually nearly approaching 200 members, more than 150 certifications issued across 39 countries. We have a wide range of audit firms in different areas that work with us to support implementation of the standards, and a wide range of stakeholders that participate in our training and in our standards development meetings and governance processes. And we have an Indigenous Peoples Advisory Forum, our IPAF, which is a really important way in which we engage with affected communities in bauxite refining and alumina refining and aluminium smelting areas around the world. So we have a big process of engagement, a big portfolio of certifications across the whole value chain that we're looking to continue to grow. So what is our certification program about? Well, we have two main standards. The ASI Performance Standard is our first one, and it sets out the practices for sustainability and human rights principles that can actually be applied by companies all along the value chain. So it's not just looking at, for example, the forest where timber is produced and those practices, but instead saying, you know what, there's sustainability issues at every stage, whether you are extracting raw materials, whether you are processing those into other input materials, the metal stage, semi-fabrication, manufacturing, and so on. All of those parts of the value chain have important sustainability contributions to make. The ASI Chain of Custody Standard then creates a link from those company practices to responsible sourcing type claims and to claims that you can make about products. And it does that by connecting certified suppliers and their customers and having a common system for accounting for material flow. So by having ASI certification against both the performance standard and the chain of custody standard, we have a global program and a global system for providing recognisable assurance for responsible practices and responsible sourcing of aluminium. In terms of uptake by country, we can see we're getting that global spread, and of course that's continuing to grow. This data is from April. That covers downstream use sectors in Europe and others, but also upstream producing sectors in Australia, Brazil and elsewhere. China is a really big part of this, the aluminium industry, both as a producer and a user, and so we have strong participation there as well. And of course this kind of global network is something we aim to continue to grow, recognising that the aluminium industry is inherently a global ecosystem itself. In terms of uptake upstream in primary aluminium, which is aluminium produced from mined bauxite ore, already in only 3 years, we have 11% of bauxite mines, 11% of the world's alumina refiners, and 20% of the world's aluminium smelters that have achieved ASI certification against the performance standard. And again, that number is continuing to grow. We have this data available to us through a collaboration with the CRU group on an emissions analysis tool, which I'll also talk a little bit more about in a moment. The chain of custody standard, of course, then comes to the flow of material, whether as a commodity basis or in particular products. And this diagram is the result of another collaboration with the International Aluminium Institute, which has for some time modelled the mass flow of the aluminium content of bauxite, alumina, aluminium, and then through products. And then, of course, the kind of scrap recovery link as well, whether that's pre-consumer after manufacturing or post-consumer after the end of life. The green stripe in there is the ASI metal or ASI material component of that, and we collect this data annually. And so far we've done that for the calendar years of 2019 and 2020. Between those 2 years, we've seen this green stripe double in size. And of course, we at the moment have a strong uptake in the mining, the bauxite piece, but of course it takes some time for supply chains to fill. So, those further downstream need this kind of uptake to start to kind of flow through and to build their own supply chains and networks. So we expect to continue to see this grow in coming years. The scrap piece is a really important one. So far we can see a sort of a thin line for pre-consumer scrap, and the post-consumer scrap, of course, is also something that we want to see not only come under ASI certification, but to reduce down material that leaves the system at any stage and start to really genuinely close all loops as part of a circular economy approach. So I'm sure we're all aware that aluminium is an energy-intensive metal to produce. At the primary aluminium stage, that's where an electrolytic process takes alumina powder and makes that into the metal. Recycled or secondary aluminium uses maybe 5% of the average original energy to produce primary aluminium, but nevertheless, it's an energy-intensive metal to use. And so when we're looking at net zero 2050 type objectives, there's a huge amount of work for this sector to do to bring down this overall emissions curve to, a fraction of what it is now by 2050. There are major shifts that need to happen for all smelters, whether they're already low on this curve, but of course, particularly for this proportion at the kind of the right-hand side of the curve that is predominantly coal-fired energy that is supporting that electrolytic process. This diagram is from our collaboration with the CRU group and shows the emissions of every single aluminium smelter in the world, and the blue component shows those that are ASI certified. As part of our standards revision, we are doing quite a lot of work on looking at decarbonisation pathways for the sector and what kinds of drivers within our standards will support that. Some may think, oh, we should only really focus on this bottom corner, but if we're taking a sector transformation approach, we really want to incentivise and create those pathways for this whole curve to come down. That may mean certain kinds of assets coming out of production. There are kind of sectoral shifts that need to happen at a grid level, you know, in a national context as well. But this piece, you know, this whole big picture is one of the ones that we're pretty focused on. So this brings us to a broader discussion about responsible sourcing. We've talked about low carbon, but low carbon and energy intensity, carbon footprint is not the only component to responsible sourcing or to sustainability as a whole. So let's think about what are these components? And I think the first group that we can look at is really access to markets. We know, of course, low carbon, there's some urgency and absolute imperativeness, you know, about this issue. And so quite rightly, this is a key focus for us and for many organisations, whether that's looking at it from a trading context, for those organisations downstream, such as yourself, that are looking to map and understand their scope 3 footprint, including through material sourcing and so on. But, you know, the challenge from, say, aluminium's point of view is how does it respond to those kinds of market expectations? So carbon is one important piece, but there are also other differentiators. So a couple of examples here. One here is an aseptic carton where the aluminium foil layer within that carton is ASI certified, and the paperboard is probably FSC or similar certified as well. So you have consumers that are increasingly interested in the material choices that they're making. May not really understand the carbon intensity, but are looking at that broader assurance of sustainability practices being embedded in all material choices. Much more relevantly for this sector, green building certifications obviously takes a broad scope, not just at material sourcing inputs, but the livability and the kind of the ongoing use of the building and design decisions that are made there. So ASI has done quite a lot of work with BREEAM and also with LEED at having ASI recognised as a material that can be accounted for in those standards and is recognised under those programs. And again, that's kind of looking at a much broader range of issues than a single metric. We also see issues such as conflict-affected and high-risk areas for metal supply chains in particular. The OECD has due diligence guidance around responsible supply chains that take account of these issues. And while they traditionally had a broader scope of materials that they were interested in, this is now being kind of broadened out to a wider range of metals, and aluminium, of course, is part of that. We've addressed those issues as part of our standard from the start, but we're digging deeper into the detail of the OECD guidance through our current standards revision and working with the London Metal Exchange to help them implement their responsible sourcing requirements that they've introduced as a pathway being through ASI certification. And finally, of course, there are material choices as specifiers, as architects and so on. You know that you are looking and comparing different materials for a range of factors, not just their technical application, but some of these sustainability considerations as well. So material choice, whether that's in the packaging sector, whether it's in the building and construction sector, these responsible sourcing questions are increasingly important in terms of accessing those markets and bringing the right kind of assurance around what efforts are being put in place, what performance is on the ground in association with those. Upstream, of course, there's also the access to resources question. For a mined material like aluminium, those resources are in certain places. There are communities and other stakeholders that are around those. And there's a really important question about equitable access to not just the impacts of those kinds of operations, but the benefits too. Guinea here is an example. And of course, we've recently seen a coup there. It's a challenging developing country context for any kind of resource development projects. And there are massive resources in Guinea that are being developed very, very quickly and creating a very challenging environment for local Indigenous communities and others. So these kind of access to resources questions can be very dynamic and have an important sustainability lens, particularly as we will increasingly find that there is no simple access to these resources. The world is becoming a crowded place, whether it's biodiversity values, community values, other important considerations that must be taken into account. The access to resources question is critically important in having excellent practices in place in terms of bringing these kinds of resources into supply chains such as yours. There is also, of course, the whole strategic materials discussion as we are looking to undertake such major transformations as part of clean energy and other transitions. There are particular metals and materials that will play a critical role in that, and some of the projections for demand are really significant. Aluminium's probably, in terms of bauxite resources, in a good place for that. But again, it comes back to the resources might physically be there, but can they be, is there regulatory approval? Is there community support? These are some of these important questions as well in terms of accessing these resources. And of course, we've talked, so far in this slide about, primary or raw materials from the ground. Closing the loop and that circular economy piece is such an important part of this as well. So, the availability of not just scrap, but quality scrap, the kinds of approaches to kind of managing scrap to separate alloy, to enhance its recyclability, to enhance the kind of mineral processing technologies that are needed for that. It's a really important piece in the material stewardship space as well. And so, pre-consumer scrap from the manufacturing stages, that's, pretty well handled. It's the post-consumer, and I think here the building and construction sector have a really important role to play. The applications in which aluminium is used have a very long life, 50, 100 years. So thinking that far long term in terms of the future recyclability is a really important challenge for this sector, and one I hope that you are thinking heavily about. And finally, of course, access to capital. The kinds of transformations that we want to see in this and many other sectors are being driven, through regulatory shifts, such as through the European Banking Authority, which is really embedding kind of sustainability considerations in all sorts of decision making. And of course, at a kind of a regulatory side as well. And then in the private sector with the financial and investment sector too, there's such a rapid pace of change where sustainability linked financing and other mechanisms just a few years ago might have been niche, but are now very much becoming mainstream, and within a few years are expected to be almost nothing but just normalized in the way that business is done. And so responsible sourcing is not just a question of one particular metric or a standard that you put in place. There's a whole change happening where programs like ASI play a role, and there's a range of stakeholders that are looking to drive this change and have access to common principles, to have common ways and methodologies of making sure we're on the right track and evaluating the impact that we're having. So I think a real key to these issues in generally, and certainly one that ASI embraces, is to take a comprehensive approach. So through our standards, we aim to address a wide range of sustainability issues, carbon footprint of course being one, but by no means the only one, and really recognising that sustainability topics are inherently interrelated. Environmental issues have human rights dimensions. Choices, that are made about developments, about product choices and so on, have a wide range of kind of impacts and flow-on effects from that as well. So thinking in an integrated way and in a systemic way is really critical. And I think the other value that ASI brings is by being very inclusive, not only of civil society and other stakeholders and the whole value chain, but the wide variety of sectors in which aluminium is used. So you have that diversity from building construction, transport, packaging, consumer durables, electricity transmission and so on are all sectors in which aluminium, features in an important way. And those sectors have different insights, different drivers, different things that they've tried in terms of advancing sustainability. And so by providing a forum where they can be shared and learn from, I think is a really powerful way to kind of leverage and further catalyse change in this important value chain. So I hope that gives a bit of an introduction to ASI. We have a lot of information on our website, so I encourage you to visit that if you would like to learn more, to reach out to me if you'd like to engage and find more about the work we could do and how you could participate. And you can keep up to date with our work through our mailing list, which you can kind of sign up for there. So thank you for your attention, and I really wish you an enjoyable event in the day ahead. Thanks a lot.
Oh, hello. My name is Justin Furness, and I'm a senior consultant with the Council for Aluminium in Building, or CAB. So the mission of CAB is to promote and defend the use of aluminium in buildings in the UK. We're a trade association. And I would like to take this opportunity to say thank you to Zak World of Façades for this opportunity to make this recording. So what am I going to talk about today? So the title of my presentation is What No D When Whole Life Means Whole Life. So by D, I mean Module D in this context, and I'll explain a little bit more about what that means during the presentation. But really, the focus is about the need to be clear about our methodology when we're talking about carbon, be that in an environmental product declaration, an EPD, or about embodied carbon. And really the need for us to be upfront about the methodology we use and why that methodology should include Module D. Okay, so a quick summary of what I'll be covering in this presentation. There'll be a little bit on climate change, a little bit on low carbon materials, and then more of a focus around the topics of recycled content and end-of-life recycling rate, and then looking, as I said, at EPD, so environmental product declarations, embodied carbon, and the standards that are available for us to use. So this slide is taken from the IPCC, that's the Intergovernmental Panel on Climate Change, their report earlier this year, the summary for policymakers, and I've chosen it to sort of summarise really where we are with the current climate change emergency. And this shows the changes in global temperature since 1850 until now. And you can see from the slide quite clearly we're already a degree hotter globally than we were some 100 years ago. And put simply, this trend must be stopped to avoid catastrophic global overheating. And correspondingly, we're seeing a huge number of initiatives to address this really important issue. And this is particularly the case in the UK here, I guess, with the lead up to COP26 in Glasgow shortly. And on the next slide, I'll just set out some of the UK initiatives that I'm aware of. So it's only right that against that backdrop, there's a lot going on in the UK and obviously elsewhere. Here I list some of the initiatives we're aware of in the UK related to this. And perhaps if I can draw your attention to, let's see, 1, 2, 3, fourth one up from the bottom, the heat in building strategy, which is keenly awaited. Alongside that, I guess we have the Future Homes Standard and the Future Buildings Standard, which really focus on the operational aspects of energy use in buildings. And over the years, the importance of aluminium fenestration systems, so windows, curtain warning typically, in meeting the operational energy requirements have been certainly a focus for our attention. Things like the energy balance concept, so looking for solar gains in the heating season, and increasingly obviously the impact of the need for ventilation in a sort of post-pandemic world is also important. So these considerations of sort of operational energy, not my focus here today, but certainly when we are tackling operational energy, the questions over, well, what is the embodied carbon that we are leaving behind in buildings? What is that actually equal to? So the focus is very much on carbon, and very much rightly so, I'm sure you'll say. And indeed, there are many excellent initiatives underway out there. And when we think of the manufacture of materials, use of hydrogen, the adoption of carbon capture and storage techniques, and particularly in our sector, the use of inert anodes. So lots of things being worked on, and I would like to actually give a shout out to two areas that are important to aluminium here. So firstly, the International Aluminium Institute's Greenhouse Gas Pathways to 2050. So this has recently been released and sets out three very credible and realistic approaches to emissions reduction for the aluminium industry. And secondly, the Aluminium Stewardship Initiative, ASI, of which CAB has been a member for a number of years now. So I'm very pleased that sharing a platform here with Fiona Solomon from ASI. And it shows us really that sustainability is obviously includes carbon, includes environmental issues, but also social issues, and also governance issues are also important, as well as environment. And so important in that aspect that we look at these things in the round. So certainly encourage you to explore more around the IAI and the ASI activities. So for aluminium, as for all metals, recycling and the methodology we use to look at recycling is clearly very, very important. And just to highlight, I'm not talking today about reuse. So obviously reuse is also very important for metals. Here we're talking about recycling. So it's well known that recycling of aluminium uses 95% less energy than producing primary material, and concomitantly that brings along 97% less greenhouse gas emissions. So clearly it's good for the environment to recycle metal, and indeed it's been done for a long time. And aluminium, it's 100% recyclable, as we say. It's a permanent material, so once you have it, it's always there for future generations. And clearly things like the durability of aluminium and the recyclability of aluminium have always been seen as key features for its use in the construction sector. But recycled content is also something that people look at, try to assess a material by the amount of recycled material. And for aluminium, there is simply not enough scrap to go round. So there really is a limit to what can be done when it comes to looking at recycled content. Also, I would say, what's the methodology that's used when somebody is giving you a value for recycled content? So that needs to be very transparent and needs to be assessed, and sometimes people use different methodologies depending on their different business models. So that's something that also needs to be considered. So really, second bullet point there, the end of life recycling rate is something that certainly for metals is preferable to a concept like recycled content. because research has shown us that at least 95% of metal in a building is recycled at end of life, certainly for aluminium in buildings. So it's reasonable to use that scenario for the future. It's what's going to happen. It's going to be recycled, and indeed it can be recycled infinitely, if you like. As I said before, it's a permanent material, and so each time you go around that recycling loop, essentially you are saving carbon each time. So really what I'm saying is that aluminium is an exemplar of the circular economy, and this is something that we need to focus on more and more as we move forward. And it's at this point I'd like to give a quick plug for our CAB closed loop recycling scheme, which is open to anyone who is a member of CAB. And three things really we aim to do with the scheme: highlight the sustainability of our material, highlight the sustainability of our members, and indeed highlight the sustainability of our members' products. You may ask, well, why a closed loop? Hasn't aluminium always been recycled? Well, yes, it's true, but certainly the use of wrought aluminium alloys, so the use of profiles, extrusions, is increasing, and we are keen that profile is returned back to profile in a closed loop. So we're really encouraging our members to sort their scrap, to get better value for their scrap, and really to maximise the volume of scrap that is available, as well as obviously highlight the fact that it's current practice that aluminium is recycled and 100% recyclable. So certainly please find out more information from our website, and indeed ask your suppliers whether they're aware of the scheme, whether they're members of the scheme. If not, why not? That would be appreciated. And also finally at this point I would like to give an acknowledgement to our colleagues that run the AUF scheme in Germany, which is along very similar lines. Which brings me to this topic of embodied carbon. So as I mentioned before, we've been able to really closely examine operational carbon, develop systems that are really efficient in terms of how a building works when it's in use. If you like, module B in the modular language that we'll talk about a bit later. And we're really keen to understand a bit more about what methodology you should use for embodied carbon. So what is the carbon that you're putting into a building's fabric to give it such a good operational carbon profile? And we see talk of an upfront embodied carbon. We see talk of a whole life embodied carbon. What do they actually mean? Well, we really do need to be upfront about the methodology that we use. What standards are we applying, for example? What are the life cycle modules that apply and perhaps more importantly don't apply? And certainly when it comes for upfront embodied carbon, this really is, generally speaking, a cradle-to-gate type of assessment. So coming back to the modules, you're looking at modules A1 to A3 only. And in my view, I think that's potentially a misguided step. Certainly for metals, it's going to be misleading for metals, and more importantly perhaps it's going to be misaligned with the circular economy and also the standards that are available and out there. So we really should be talking about whole life to avoid any unintended consequences later in the life cycle of the building. And we really need to look at the relevant standards and promote the circular economy. So simply put, in modular language, we don't need just the modules from module A. We also need to think about C, which is what happens at end of life, and module D, so the reuse and recycling of the material. So where does this concept of modules come from? The concepts of module A, module B, C and D. Well, I reproduce here a table from the standard EN 15804, and this is the standard that sets the rules for making environmental product declarations. And note the version reference at the bottom there is the latest version of the standard. And we'll start by highlighting Module A. So you see in Module A you have essentially the 5 sub-modules. So modules A1 to A3, essentially cradle to gate, and then modules A4 and A5 covering transport to site and installation. So after Module A you get the use phase, which is Module B, which is not highlighted by me, and then I will highlight modules C and D, end of life and recycling reuse. So you'll see in this table that there are 5 rows at the bottom there that set out the requirements for different types of possible environmental product declarations, or EPD, using this standard. So the first 3, you've got cradle to gate with module C1, C4, module D. Next one, cradle to gate with options, module C1, C4 and module D. And then you've got cradle to grave and module D is the third one there. And you'll see it labels those stages that are mandated in those different EPD, and for each of those 3 types, modules C and D are mandated now in the standard. I suppose it's worth saying that there's 2 options at the end there, cradle to gate and cradle to gate with options, where modules C and D aren't mandated, but those are for very specific conditions where they're exempt from those requirements. So the product is physically integrated during installation, or the product, you can't identify it because of physical or chemical changes during that installation process. So essentially modules C and D are mandated, and one way I like to think about it is no module D, then no EPD. Indeed, no module D, then really no embodied either. So this recognises the importance of the circular economy, and that whole life should mean whole life. And if you're looking at an EPD, or indeed looking at embodied calculation, embodied carbon methodology calculation, you really need to ask, does these include modules C and D? And if not, why not? And here we have a clear methodology, a clear statement that modules C and D are mandated. Well, we really should be using it. I really don't think I can put it any better than this quote, which is taken from the whole life cycle carbon assessments guidance produced last year by the Mayor of London's office. I'll give you a few seconds just to read that through. So it really makes it clear that whole life really does mean whole life, and we must be upfront about this methodology when we talk about both environmental product declarations, EPD, and particularly when we talk about embodied carbon. Indeed, here in the UK, there's some work underway to look at making proposals to include embodied carbon in our building regulations. And 3 points I'd like to make there really. We need to be very clear. We need to ensure that we're upfront about the methodology that we use. We must ensure that that methodology includes module D, and we should ensure that way that whole life really does mean whole life. So for my final slide then, I'd like to leave you with this image, and apologies to Kilroy, whoever Kilroy was, but we really need to ask when we're looking at things like embodied carbon, when we're looking at the circular economy, where is module D in the assessment? We really need to be upfront about this. And simply put, in my view, no module D, no EPD, but also no D, no embodied either. So thank you very much for your attention, and I hope three things. I hope we've seen the importance of reducing carbon. I hope we've seen the importance of the work of the aluminium sector in reducing carbon, and I hope we've seen the need to look at the circular economy and to think about whole life and look at the end of life stage for aluminium in particular. So in conclusion, no module D, no EPD.
Hi, thank you for inviting us to Zak World of Façades. My name is Lena. I'm working for the Cradle-to-Cradle NGO in Berlin in Germany, and I'd like to give you a little insight now into the concept of Cradle-to-Cradle. Why Cradle-to-Cradle? Let's start by analyzing how we act today, how we design products from toothbrushes to buildings, how we produce and consume them, and what happens after their usage. The problem in our linear economy is that most products and materials end up as waste. Instead of acting from cradle to cradle, we act from cradle to grave by taking and exploiting our natural and finite resources to create products and then throw the resources away. Agriculture is a good example for how we exploit nature and take so much more than we give back. Monocultures, the usage of pesticides and so on are only two explanations for why we lose so much fertile soil. Another good example is our usage of plastic. We produce roughly 80 million tons of plastic packaging annually. Some of it, at least in some countries, is collected within waste management systems. Some of it ends in landfills. And more than 1/3 is leaked into nature, mostly ending up in our oceans where they harm our ecosystems and us humans as well, because we consume microplastics when we eat fish or algae. The common conclusion after seeing how we exploit resources and produce products that end up in the wrong spots and harm ecosystems and our health is we humans are the root of the problem, so we have to reduce our mistakes. So the strategy is to strive for zero, a strategy where we cover up our harmful ecological footprint and are most successful if we've completely removed all traces of it. But we think the strategy is neither applicable as a solution on a global level nor realistic. Zero carbon emissions, when do we humans have ever been carbon neutral? Never, because we breathe. The classic concept of sustainability means while we try to increase our economical wealth and increase the quality of our social structure, we try to reduce our ecological footprint. Michael Braungart and Bill McDonough took another approach to conceptualize the difference between being less bad and being truly good and beneficial. What if we also try to maximize our ecological footprint? The positive ecological footprint we can achieve as humans. To get to this positive footprint, we need to rethink how we measure success in protecting our environment and thus our livelihood. Today we try to be efficient. Think of the packaging that says it contains 3% less plastic or products with a free from label. Is that really what we need to know? In the current way of thinking about sustainability goals, yes. In efficiency, we are still thinking about end of pipe solutions. We are not innovating, or we are innovating that wrong thing because we are not going to the root of the problem, the design of a product. Effectiveness, on the other hand, gets to the essence of the issue. Setting the right goals, thorough and well thought through. So in cradle-to-grave, in a cradle-to-grave scenario, where humans are the problem, the best we will ever strive for is to reduce said toxic and negative footprint of humans. However, in a paradigm shift to cradle-to-cradle, humans are seen as contributors and fundamental components of the circular system on this planet. So what does cradle-to-cradle mean in this context? C2C is a school of thought, a mindset, which describes how and why we have to rethink the way we act today, which is, in a nutshell, what I told you in the past couple of minutes. But C2C is also a design concept, which basically explains how we implement the theory we established in the school of thoughts to every product we design and produce. The C2C design concept does not only apply to products, but also to the circular services and business models. In this C2C mindset, everything is designed for a specific use scenario according to whether we use or consume products. We design them either for the biosphere or for the technosphere. In the biosphere, products are biodegradable. After we consume them, they are a nutrient for the biological cycle. In the technosphere, products are designed for recycling. Components must be separable without residues and recyclable without decreasing the resource's quality. As for production, we use only renewable energy sources, as the sun sends 100-fold the energy humanity uses to Earth every day. Water leaves the production in drinking water quality, and social fairness applies along the entire value chain. Here are the two cycles with product examples. The biological cycle, meant for products that experience abrasion and wear off during their use phase. Products where it is not possible to avoid that parts of it or the whole product end up in the environment. Those need to be made of naturally decomposable material. The technical cycle is for durable products where no abrasion takes place during use phase. Those can be disassembled after use and reused. If we design products for those cycles, all resources circulate in continuous cycles and become nutrients for new products over and over again. Maybe the most distinctive aspect of C2C is the big focus on material health. The goal is to use defined materials that are healthy for people and the environment. Ultimately, there shouldn't be any free-offs anymore, as substitutes for forbidden substances are often equally toxic to our health or the environment. It is more important what substances a product does contain than which ones it doesn't contain. An example is the use of asbestos in brake pads for cars, as asbestos was banned in the 1990s because it was found out to be carcinogenic. But the substitute substance, antimony sulfide, is actually carcinogenic as well and currently under review. No asbestos, but still equally harmful. How can we improve circularity even more through services and business models? Service concepts or so-called product service systems can be very useful to facilitate keeping materials in cycles. Basically, it is about not buying the ownership of a product, but only the service of using it. It is much easier for the producers to get back and plan with the materials that are built into products when the ownership remains with them. The product becomes a material bank when every component can be reused endlessly. The best example for a material bank is a building. The construction sector is one of the industries in which C2C already has been proven to work. A lot of great C2C projects, which I will show you later, exist already. And from our perspective, it is a crucial industry that urgently needs to transform. In Germany, the construction sector stands for 60% of the total amount of waste we produce in Germany, and it is roughly the same number on a European level. The usage of buildings as material banks contributes directly to a circular construction sector if we construct and design according to C2C criteria and build with C2C materials. Ultimately, it increases the residual value of buildings because as long as the materials are part of a building, they maintain their value or the value even rises, which for some materials is very likely due to the scarcity of resources. A material bank gets even more useful if all the information it contains is digitalized in material passports. If we stay in the construction sector, this would mean that for every material we put into a building, there is a vast amount of information about the substances it contains, where it was fabricated, if social standards were respected in the production facility, and how it was built into the building, as well as how it can be removed from the building without residues. It is the ultimate transparency tool for consumers and companies, as it holds all the information about a product, its quality, and its entire value chain. Now I will shortly introduce you to the C2C NGO. We are a non-profit organization based in Berlin with about 25 to 30 employees and steadily growing as our range and work is growing as well. Our main fields of work are education and networking, but also the initiation of C2C projects by encouraging and supporting actors to realize C2C. The Products Innovations Institute certifies C2C products. We, as an NGO, we do not certify. The products are being certified on criteria from bronze level to platinum level in areas of material health, circularity, clean air, climate protection, water and soil stewardship, and social fairness. Some of you might recognize the zinc logo in here, a German manufacturer of fire galvanized steel facades, among other products that are C2C certified. There are some companies in the building sector that already produce cradle-to-cradle building materials, from flooring systems, window systems, partition walls, insulation materials, wall paint and tiles to pipes, fittings, and entire timber construction systems. Let's take a look at some of the buildings that already were constructed according to C2C criteria. It is important to mention that there is no certification for buildings, but a C2C building can be easily removed or reconstructed without the emergence of waste. It is constructed or renovated with circular and healthy C2C products and construction materials. It increases biodiversity instead of harming it, and it produces more renewable energy than it uses. A great example for public buildings according to C2C is the City Hall in Venlo in the Netherlands. Additionally to all the benefits listed here, like green facades, use of rainwater, solar energy, and the reusability of all materials, is that within the first year of usage, the sickness absence rate decreased by 20% because the employees now work in a healthy building. And the City Hall was cash flow positive within the first year. Both are very important factors when we talk about public buildings like schools or universities. Another great example for a building according to C2C is the Moringa project in Hamburg, which is currently in the planning stage. This is going to be a 20,000 square meters building with 17.7 thousand square meters for housing. It is a great project that wants to prove scalability of cradle-to-cradle in the context of housing. There will be more horizontal and vertical green than the amount that was sealed due to the construction, and all materials used in the building are recyclable or biodegradable. In its entirety, more than half of the building complex will be removable without destruction, so resources can be reused. Now, the Venlo City Hall and Moringa are new builds, but C2C is also a great approach for refurbishing existing buildings. My favorite example for a renovation is, probably not very surprisingly, our own head office, educational center and living laboratory, the C2C lab in Berlin. We renovated a former pharmacy in a typical Berlin Plattenbau from 1986, which was full of toxic materials, for example, the PVC flooring and some insulation material. We took all of these materials out, except, for example, for some of these tiles you can see here, and we refurbished the entire 400 square meters with C2C materials and C2C products. Yeah, and this is how it looks today. The carpet tiles, the acoustic panels on the walls, the ceiling buffers, the window systems, the partition walls, including the glass, the lamps, the building of the pipes and the lacquer we painted them in, as well as the wall paint, everything is cradle to cradle, even the office chairs. Yeah, and here you see another example for one of our office rooms in different colors. Yeah, and this is where we work from today. Thank you for listening. I hope I could give you some inspirational new information. And yeah, if you need any further information or if you have any questions, feel free to always reach out to us. Thank you.